Okay, we continue. Continue. We say the last person should have a negative sign x, and we shall put that one up here. So f dash of x is giving us a negative sin x. Like that. I also add that d the x of that one means that when we differentiate a cos x with respect to x, we write d divided by dx of, you put in brackets, of cos x gives us a negative sin x. What we have done, we've done it from first principles. We've differentiated cos x from first principles. This one means that the derivative of cos x, the differential coefficient of cos x, the derived function of cos x, that is, we write it as that. Or when you differentiate cos x with respect to x, you'll get a negative sin x. And since I've done mine, I've done the toughest. I want you to try sin x and you tell us the result. Do it faster and you tell us the result. Try it aside. You only tell us the final result. You tell us the final result.
Excuse me, teacher.
Yes, please.
Teacher, how did we arrive at negative sin x, like from the second last step?
Okay, we said at this point, our h in the denominator cancelled out, right? This h cancelled out. Now, if h cancelled out, we remain with this. From here, how did you arrive here? I saw comments giving us negative sin x. How we arrived there, we said you're computing the limit. To compute this limit, as long as you've cancelled this h, this one which is dividing, as long as it cancels out, you can now go ahead and compute the limit. To compute this limit, simply replace where you have h, put a 0. And you see that when you put here 0, you remain with a 2x divided by 2. 2x divided by 2 gives us only x. So the result will be negative sin x. And that is what we have. The result will
Okay.
be negative sin x. That one up there. So I want us to try the derivative of sin x from first principles. Try the derivative of sin x, Roman numeral 2, from first principles. And you also tell us what you get. I have 5 minutes for that case, but you shall break it into 3. Utilize 3 minutes and you will give us the final result. Okay, I see cos x, cos x, cos x. Somebody came late. Yeah. Next time come earlier, please. Okay, cos x, cos x. Yes, to those who are stuck a little, it is not hard. Just go back to your information behind the previous example. We are going to use the same thing. Here, we said let fx be equal to cos x. Just change. Let fx be equal to sine x. Just change where you see cos. Just change that. That will have our fx as sine x. Of course, f of x plus h will now be sine of x plus h. Everything is similar up to here. When you substitute in your formula, this will be sine, the limit as h tends to 0 of sine x plus h minus sine x. What will only change is in your factor formula. You now need to go back to your factor formula and check what is a sine of an angle minus a sine of another angle. We said sine minus sine gives us a 2 cos and then sine. So the first angle would be, we say the first one is 2, we said you get 2 cos and then sine. The first angle here, you simply add this one plus that divided by 2. The last angle, you subtract the first one minus the last one divided by 2. So I'm only changing here and then here. So that one remains. So you say you get 2 cos first, cos. The first angle, x plus h plus x divided by 2. The last angle, this will be sine here, will be similar to this, x plus h minus x divided by 2. So you see that these ones only change here. It is only this one which changes, only this to cos. Do not forget, make sure you state this. If you leave out this statement, then everything below that collapses. However correct it is, ensure that this one is not left out. After reaching this stage, you're seeing sine of h over 2 suggests that since h is small and it is in radians, therefore sine of h over 2 is approximately equal to h over 2. Do not just write the next result before stating that one. Make sure you state that your angle h is small and it is in radians, therefore sine h over 2 will be approximately equal to h over 2. And the next, the same here, this one has only changed it to cos. That is cos. The remaining information comes to what we have here. This is cosine. And you will see that still, since you say this is approximately equal to h over 2, you have it here. This 2 goes with this 2. That h goes with that one. And you're left with now a cos of 2x plus h over 2, which will now simplify to a positive cos x. And that is your derivative. So this will be positive cos x. And you can therefore say did x over sine x gives us positive cos x. Just like that. Okay? Once again, The next one is yours. Sine 3x. Sine 3x is 1. And we take a break. Make sure you have some water. Take some water. If you don't have water, you should have coffee like me. Okay? Somebody is tired of writing the limit as h tends to 0. Obviously, you don't get tired. You are still young, energetic, and the other things I will not mention. So do not get tired. It is part of our working here up to this second last stage. When we are still putting it there because we have not yet evaluated that limit. What we are doing with this is to simplify. We are still simplifying until we reach a stage where we can evaluate the limit. That stage is when this h, which is dividing here, cancels out. Once that h cancels out, you can now celebrate like Arsenal fans after scoring Man U. That I can now evaluate my limit. So we take a coffee break, not 10 minutes. 10 minutes is much. A break as you're trying sine 3x. Okay, thank you very much. Those having Nkunda Mariam has 3 cos 3x. Mike Asingwire 3 cos 3x. Serunkuma. Okay, that is very good. Kiese Guja. Wow, that is nice. Futimukiza Precious. Yes, I see. That means we are doing well. For those who are stuck, I don't know. In case you're stuck, you can wave to us, or you Rone Nkizi. Okay. Yes, I see good results. That means we have been attentive all through. To those who have been defeated slightly, if you've been defeated, I'm using this same example used previously. We are just going to change something small, just slightly, and we have the actual result that we want. Now, what changes here is that the angle here, it is a 3x. Therefore, you're going to change this. This is 3x. Then, since you're replacing, where is x alone? We are putting x plus h. Therefore, that 3 will be outside here. And you have sine of 3 into x plus h. And then we go and replace into our formula. Substituting into our formula, you can see up there. And see up here changes only here and then here. So you have this as sine of 3 into that minus sine 3x. Only that. Now, since you're utilizing factor formula, we also get the same result as this. But of course, here is a 3 into x plus h, and then this is sine 3x, of which in case you factored out that 3 will be here. Likewise, the 3 will be here. Kind of that. And if you continue and simplify well, you see that you have this is the 2 cos of 3 into that. If you expand it, then here would be 6x plus 3h over 2. If you also expanded here, then of course here would be 3x plus 3h minus 3x over 2. Now, when we continue and simplify this one here, of course, x and x goes. If you had inside 3x plus 3h minus 3x goes, and you're left with only 3h over 2 for that last part. So I'll have a 3 around here. I'll have a 3 there. Okay? Then in this one, my 3 will still, you can still keep it outside. Kind of that. So you have cos of 3 into 2x plus h over 2. Do not forget the approximation, since h is small and in radians. In this case, you have sine of 3h over 2, sine of 3h over 2 being approximately equal to 3h over 2, like that. Then, of course, these ones will remain. You have a 3 inside here. So this is a 2 cos 3 into 2x plus 1 over 2. And this last one here, is 3h over 2, like that. Here, first remove this. So it generates something resembling that. Those who didn't get it, it should be resembling that. At that point, that is when we see that h cancels out, can begin by cancelling h. There is this h going with that one. There is this 2 down here going with this 2. And you are now left with a cos of 3 into 2x plus, this is meant to be h, this one here is meant to be h. You remain with a cos 3 into 2x plus h over 2. So you have limit as h tends to 0 of cos 3 into 2x plus h divided by 2, like that. Now that this h has cancelled this one, at that point we are able to compute our limit. And to compute the limit, we simply said substitute where there is h, that h put is 0. And you see that if h is 0, here we shall have 2x over 2, which remains as x, and then multiplying by the 3 outside will now give us the final result as the cos 3x with that 3 left it out. There is a 3 we left out here, this one. It should be here. So you have the final result as 3 cosine of 3x. Those who didn't get it earlier on, please check through. And you also have the same answer as we have here. Like that. Okay, those who got it, congratulations. The one of tan x is now giving us headache. The one of tan x, we shall do that together. Then I'll leave you with the enough exercise to do. So those who didn't, please copy so that we are at the same page. Those who didn't get it earlier on, I want you to copy so that we are at the same page. Remember that so any complaints, I want to hear your voice, unmute and talk to us. Wemba Serena. Okay. Right. I believe some people have gotten some answers. Someone has sec squared to sec squared x. Somebody here namonoke sec x squared singwili. I think it is sec x squared. Don't just think. Yes, I want to see the actual working. We try and do it together and see what we generate. Okay. We are beginning with the fact that let's use this upper part, the whole of it. Beginning by saying let fx be equal to tan x, like that. If fx is tan x, that implies that f of x plus a smaller change in x, which we are using as h, will be tan of x plus h, like that. In our formula, f dash of x, we know is the limit as h tends to 0 of f of x plus h minus f of x divided by h, provided h is not 0. When we substitute here, we say that we have the limit as h tends to 0 of tan x plus h, subtract tan of x, then divide everything here by h, like that. At that point, these people will get stuck. How do I proceed? And I'm seeing already some got stuck. You can proceed in two ways. One, just you know the factor formula for tan minus tan, which we probably didn't learn in class. But you never know, we could have learned with one or two members. We also have factor formula for tan. It's there. Don't say it doesn't exist, it does exist. For us who didn't learn it, what we shall do is to write this in terms of sine and cos. You know, tan of any angle is equal to sine of that angle divided by cosine of the same angle. So we're going to utilize that one here. And that will happen for other cases like cosec x, cot x, and then sec x. You need to write them in terms of sine and cos, then you can proceed. Okay, we continue. We can now say our f dash of x has become the limit as h tends to 0. Tan x alone, we say it is sine of the angle x plus h divided by cosine of the same angle x plus h, minus tan x will be sine x divided by cos x, and you're dividing everything here by h, like that. Okay, at that point you go ahead and get the LCM for this numerator, this part here, get the LCM and combine them into a single fraction. combine them into a single fraction. If we do that, we shall now see that we have here the limit as h tends to 0, limit as h tends to 0 of the LCM of this and this will be the product of those two, cos of x plus h and then cos x, like that. Then you know that you get LCM divided by this one here, we remain with cos x. Cos x times the numerator will give us sine of x plus h cos x. Then minus, here will be sine x and then cos x plus h, like that. Now, since we are dividing everything by h, I said it is better I can write h here or I can put it here. You're dividing by h, so it will just come and multiply the denominators here. You can put it here or to be in front this way, but we're not in front for this case because it may look like xh is an angle. So it is better you put it at the back of this trig functions. So you have that. Now, I want you to utilize your knowledge of trigonometry. You tell me what the numerator simplifies to in the comment section. What does the numerator simplify to? What does the numerator simplify to? It should simplify to something very small. Look at it critically. Think in a line of expansion. What was expanded to give the numerator? Look at it critically. Then you tell us what you generate finally. Yes, I see answers. Sine of 2x plus h, there is sine h, there is h, there is h. Okay, I think the best result that I wanted, first of all, is from Namutosi. Namutosi Desire, thank you. Fitimukiza, thank you. What was expanded to give the numerator is a sine of, you can call this angle A and your x is angle B. You see that when you expand sine A minus B, you get sine A cos B minus can begin with cos A and then sine B from the expansion of sine A minus B. If you relate, x plus h will be your A and then your B will be x. So from that point, we can therefore write that this is equal to the limit as h tends to 0 of sine. First write it in this in that format, minus x, can put this in brackets, then minus x, so that you distinguish that this is kind of angle A and the other one is angle B, divided by h cos x plus h and then cos x. For your information, we don't do anything to the denominator. What we only struggle to have is to find a way of cancelling this h in the denominator. And to cancel this h here in the denominator, the result should come from the numerator. Now at that point, you can see that when you open here, x cancels, and we are now left with only the limit as h tends to 0 of sine h. Divide this by h cos x plus h cos x, like that. Now at that point, that is when we can use our approximations. You suggest that h is small and in radians, therefore sin h is approximately equal to h. Do not forget to write that. Do not forget to write it. So you say h is small, you can write the whole statement. Since h is small and in radians, sin h is approximately equal to h. Or you can simplify and write, just write h is small and in radians, comma, the implication is that sin h is approximately equal to h. That is now when you write the second or the third last step. Limit as h tends to 0, h, this one has become h, divided by, I have h, cosine of x plus h, cos x. And at that point, I want to leave it there. I take my break as I wait for the final result. I want you to continue. You show that this h has cancelled. And then you help me compute the limit. You tell me the final result exactly. I'm waiting for your comments. Okay, thank you very much. There are those who have gotten the result. There are those who are still stuck. There's some gentleman called Zoom user. We are sorry. Next time you put the correct name. We want to see your name like Simon, Troy, Kisuki. Those are correct names. Micah Singwire. Are the names I want to see. So for you, you have seen us for today until tomorrow. When you put the correct name, you'll come back. We want people that we know. We don't want Zoom user. Yes, thank you. Okay. We complete it. So the second last is simplify to get as f dash of x as this is visible. F dash of x as limit as h tends to 0. So this h cancels, so you're left with only 1, the numerator, over cos x plus h, and then cos x. At that point, you can now evaluate your limit. To evaluate our limit, we simply said replace. Where we have h, put 0. When you put a 0 where we have h, at this point, we don't again put a limit as h tends to 0. Just write cos x, because I've put h as 0 times cos x. And we know cos x times cos x will give us a cos squared x, and 1 over cos squared x, we said in our trigonometry, is a sec squared x. Therefore, if you differentiate tan x, you'll get sec squared x. Ladies and gentlemen, that is what we have. To differentiate tan x, you'll get sec squared x. Yes. Anyways, somebody has issues, but I want us to be able to recall identities. For example, we said in those trigonometric identities, you need them. The expansions, you need them so that you are able to do the work I shall leave you with. We have the expansion of cos of a plus b. Should be able to recall this is cos a cos b minus sin a sin b. You have the one of a minus b, you simply change here to b plus. You have the expansion of sin a plus b. We say that gives us sin a cos b plus cos of a sin b. So if here is sine of a minus b, then here will also be minus. Look at the difference between this one and that. For the case of cos, if here is plus, then there is negative. If here is negative, then here will be positive. For the case of sine, whatever is here is similar to what will be here. Okay? So if I have sine a plus b, even here is going to be a plus. Don't forget sine a cos b plus cos a sine b. In that order. That is the identity we used to simplify this numerator into this. You're seeing here a negative. Therefore, we are using an expansion of sine a minus b. When you compare these angles, the first angle here, x plus h, will be corresponding to a. And then the last angle here, that is x, corresponds to b. So in that expansion, if you come back and replace in this, that will be sine of a minus b. My a will be x plus h. My b will be equal to x. Then you can simplify, and that will now give us sine h. After reaching that stage, you don't just say that this one cancels with that. First make that statement. That statement should be seen. H is a small one and in radians, therefore sine h is approximately equal to h. Then you replace it, h cancels, and you get this result. From here, compute the limit by simply putting where we have h, put 0. You get this one, and finally, that is the final result. So do not forget those identities. You'll use them. For today, I think we shall end there, but you'll try some few numbers. You try some few numbers here. Your job is to prove the result. You're going to prove the result from first principles. You're going to prove that so you do that from first principles. Just like the way we began, this x is, we call it a differential operator. Is simply asking you that differentiate sec x with respect to x. So your job is to show that when fx is sec x, f dash of x will give us this, or ddx of sec x will give us sec x tan x. The one of cot x should give us negative cosec squared x. The one of cosec x should give us negative cosec x cot x. Try that in your free time, and we meet again the next day. Thank you for attending and listening. See you.